Okay.
Like it's the feedback.
Great. Yeah. Perfect. Okay. Are we good? Okay. Hi, guys. My name is Sara. I am a senior protocol engineer at Uniswap Labs. And this talk is called 500 Days of Security Summer. It's not actually 500 days. We did not actually spend 500 days on audits and all of that, but it's sort of a nod to, I think, this sort of robust process we went through in securing v4. And I'm going to talk a little bit about that today, but I'm also going to talk about the 4, I guess, main phases, at least how I think us at Uniswap and probably a lot of other protocols think about when we write a new protocol, what are the 4 kind of big phases we think about, and also how do we think about security at each of those phases. So the design phase, like what does the architecture look like? What's going to be a usable architecture, but what is also less vulnerable to security issues. At the building and testing phase, how do we implement really good testing practices in reviewing PRs, and then finally at the auditing phase. And so we'll kind of see like little examples, at least from my experience, of where we've thought about security and brought it into building v4. So first, I have been working on v4 for over a year now. This was before we really had hardened code for v4. And we had a vague idea of the architecture. We knew we wanted a singleton contract. We had sort of this lock and call style architecture that's really kind of the key security mechanism in keeping pools essentially solvent. And then we also knew we had this kind of flash accounting system. We wanted to use transient storage. There was no transient storage available yet in the EVM. And so there was a lot of moving parts with the architecture, and I'd say it's quite complex, especially if you compare it to sort of v3, where we have the factory models, and each pool is their own contract. Right, in v4, it's all pool storage is held in one contract. So that was kind of complex. And on top of that, we had a huge feature set. So like v3, it's a concentrated liquidity style AMM. But it sort of builds on the expressiveness of v3 with hooks, right? So that's already scary in itself. We're basically allowing at predefined points in the life cycle of a transaction you to call to an external contract, any external contract defined by the pool creator. We have donate. This is donating to in-range LPs. That has some interesting implications that v3 didn't have. Unlimited fee tiers, dynamic fees, ERC 6909 wrappers, this feature set is huge. And on top of that, there was one really big feature as well that we wanted to get into v4, which was custom curves. And I'll talk about that in a little bit. The first thing I want to touch on, though, is hooks. We had a few different designs for how we were going to design sort of this call out to various hooks. So for some context, hooks are addresses defined by a pool creator, and they basically allow the creator to specify at what point in the life cycle of a transaction can you call this external contract. And the key, I think, feature with hooks that is really great is that you have to predetermine what call sites those are. So is it before swap, after swap? Is it before initialize, after initialize? Before modify, after modify? And those are unchanged. They're defined in the hook address. You can't change what call sites or what permissions a hook has. The other key thing to know is that in creating these hook permissions, we eventually realized that there were certain permissions that are quite scary. So if you think about modifying liquidity, you can add liquidity, you can remove liquidity, you can do it at the same transaction. Let's say if you're rolling one position into another. The scariest action is when you remove liquidity, right? You could build a hook that isn't intentionally malicious, but reverts on accident with a bad parameter. What happens when the hook reverts when you're removing liquidity worst case is now your liquidity is bricked in the pool. And that was a really big kind of like scary situation. And so one thing that we did in designing V4 is we actually added new flags into, instead of just having the before modify liquidity and after modify liquidity, we actually split these flags out into 4 flags. This was really important because we had to distinguish between adding liquidity as an action and removing liquidity as an action. And so really the key learning here and sort of going through some of the design for building hooks and sort of defining some of these permissions is make these permissions as granular as possible. It has sort of implications when you think about building routers and liquidity management contracts, right? Of if I can feel like, okay, I'm calling a pool, but I know that I'm only caring about routing for a swap. This pool doesn't have the before and after swap flags, so I basically don't have to care what the other permissions are. And you can kind of extend that when you think about the kind of plethora of permissions that hooks can have. This was a really interesting principle that came up as well when we were designing custom curves. So for some context here with custom curves, it's really essentially the ability to bypass or override the concentrated liquidity model that's like the V3 or V3 style, or the X times Y equals K curve. We wanted to basically allow hooks to be able to write their own curves or define their own kind of exchange rates on pools. This is a huge design space. We probably had around 4 or 5 different designs, and all of them kind of pulled and pushed at these different kind of trade-offs. So code complexity, flexibility, composability, and sort of integratability, and then security. And you can imagine, like, if you think about code complexity, sometimes writing like a ton of code actually might be worse for security. Because you're potentially adding a lot of code to really hot paths in the code base. But reducing that maybe increases the flexibility of what can happen at the protocol, but then is a lot scarier safety-wise for users. And so there was all these various designs, and it was really a matter of choosing one that we felt good, that could hit sort of a mixture of these trade-offs. So at one point, on the left, you'll see this diagram for this super easy custom curve implementation. It was a crazy design. We essentially allowed a hook to be able to apply deltas on behalf of a user if it had a certain permission turned on. And what that means is essentially you could do things like a user has asked to swap 100 USDC. A hook, in theory, could then say, okay, well, I'm going to give the user 100 DAI, but you know what? I'm also going to give the user, I don't know, 0.2 ETH or something, like as a reward. So you could have these really interesting features. This is like a try pool. You could natively have a try pool. What was scary about this design, though, was that we were kind of adjusting the locking mechanism. It was not a ton of code, but it was also harder to test. There was sort of infinite possibilities a hook could do in this world. We iterated that a little bit, and we actually ended up making the constraints more defined. So one of the key things that I was talking about in the previous slide was sort of making these permissions more granular. In the old design, we had one flag that was any hook with a custom curve flag could have this permission. In the current design, which I'm much happier with and I think really prioritizes user safety, we have much more granular permissions. You can see these 4 permissions here outlined: before swap returns delta flag, after swap returns delta flag. And the design basically really hinges on this invariant that a user's balance always changes by their specified amount. So if a user specifies, swapping 100 USDC, they will swap 100 USDC. A hook cannot say, actually, we want the user to swap 110 USDC on the pool. So that was like a really important invariant for us to keep, and it meant that we actually had to increase some of the code complexity. We have more checks, more kind of sanitization around our hook call sites. But it also meant that we could do more specific testing around these kinds of behaviors for hooks. And so ultimately, we favored sort of security and safety in this regard when we were building custom curve pools. And again, it hinges back on the fact that we liked this design principle of separating out hook permissions and limiting them where possible. Okay, into the testing phase of V4. I put it kind of coupled with building because I think as we were building a lot of the features, we were also heavily testing them. We had all the basics, unit tests, fuzz tests, integration tests. But we actually made a switch very early on in the code base to use Foundry, and we were able to leverage a lot of their really interesting and great kind of testing suite properties. We have some high fuzz runs in CI. We use FFI for some really interesting math testing, like making sure the math makes sense. We'll implement something in JavaScript and we'll test it against Solidity. But there was one really interesting contract that we wrote with regards to testing that I want to call out. But first, I'll go into some of the testing frameworks that we used. So when we went to go write an integration test for swap, we'd have to go build these custom routers. So we have this pool swap tests.sol contract. And basically what that does is it unlocks the pool manager and then processes the request and then settles all the deltas on core. And so you need this kind of router, this test router, for any kind of swap test you want to do. So we built all these routers for swap. We built a router for modify liquidity. We built one for donate. They were all custom contracts for each of these paths. This was really nice for simple-ish tests where we're just testing a swap or we're just testing a modify liquidity. It's not so great when you think about kind of combining actions, the more advanced flows. But those flows are really important because that's one of the huge, I think, benefits of V4 is you can couple all of these actions within one call to the pool. So if you want to say, initialize a pool and then swap, or then add liquidity and then swap, or if you want to add liquidity, remove liquidity all in one go, you can do these kinds of actions. And so what we built was the actions router, which I love. I think it's a really cool testing kind of infrastructure that we built. It's sort of this very generalized contract. It allowed us to test all of these sorts of interactions between swap, modify liquidity, sync, settle, take, mint, burn, all these things that you can do on core all in one. And it ends up, it's really quite extensible. One of our auditors even built on top of this actions router and added new types of actions you could test through. And the coolest thing I think about this is that it allowed us to check certain properties while we were testing swaps or add liquidity. So if we wanted to do a balance check in core, we could do a balance check in the middle of the test. Or if we wanted to check the transient storage variables, we could do that in the middle of a test as well. And so this is kind of what it looks like. But you can see we have all these actions defined, like take, syncs. We have assert balance equals, assert reserves equals. And this ended up being a really important kind of contract that we built on, even in periphery. So if you think about the periphery code, this is all of our routing code. It's our liquidity management code. We adopted this style of actions routing in this unlock callback for both of these contracts as well. which is kind of pretty cool because it started as just something we needed for testing and now is something that we use in production and is something that I would also recommend for people if they're working on integrations with Core, is a pretty good framework to think about how do you batch actions on the pool manager. The last thing I'll call out for testing is, I think this was a really cool thing we did. We fuzzed certain actions against V3. So I like to think about V4 as really like a superset of V3. We extend on all the math and everything that V3 uses. And so if we could, fuzz that swaps and modify liquidities are equivalent to V3, that's a pretty cool benchmark. Reviewing. This was honestly probably a lot of my time in the last maybe 6 months is PR reviews. And this is like, I think myself and also the rest of the team spend most of our time just reviewing. And I would just say, like, we spend a lot of time doing nits, and we didn't really settle for finishing reviews quickly or trying to meet a deadline. And the other thing that I think was really interesting is that we had to sometimes assume that code is malicious. We've had V4 open source for over a year and get community contributions into the code base, and we always have to review those in mind with the assumption that maybe there's a bug being injected here. And so that's a really important thing I think to keep in mind as we're going and reviewing community PRs, but also internal PRs. Like we have to we have to basically doubt the code when we review. And then finally, the audits. This was sort of the last phase of securing V4. We had 9 total audits. A 2.2, maybe even greater than that, $1 million competition. And we spent around 5 months doing sort of a water flow of audits and competitions. This is what it looks like. So we actually, back in March, kind of scoped out what the audit process would look like. And you can see it's sort of like a water flow, a waterfall of audits where, May, we start the first 2 audits on core, and then we start another audit a few weeks later, and we incorporate those changes, and then we do another core code audit. Same with periphery, and then finally the competition to wrap it all up. And I think, the key thing here from this is that we kind of liked this idea of audit stacking, where, yes, by the time the first audit started, the code was frozen. But as we went on through the audits, we knew that the code would change. And so being able to incorporate audits later on in the process was really important for us. And actually, we had found mistakes from audit fixes previously found in later audits. So it was really key for us to have that audit stacking. And then finally, just I think the last thing to call out is sort of having a diversity of expertise in the audit firms that we worked with. So, and this is just a call out that there were some really great findings, I think, unique to each firm that we worked with. And, some I think found, maybe more focused on math heavy pieces, or some focused on, longer term integration wide bugs. We did formal verification. So I think having all of these lenses on top of also opening it up for the community to look at the code and find something was really, really important for us. So where we are today, V4 Core is frozen. What is next? We are going to be announcing something on Monday at Uni Day, so stay tuned. And a bug bounty. So I like to say that, security definitely doesn't stop at the audits. We, are still continually thinking about monitoring. We're thinking about hook security. I think there's a ton more we can do even once it's live. And so with that, thank you all for listening. I don't know if we have time for questions, but if people want to ask questions.
Hi. Yeah, I've built a few hooks in the past, and like some of the main issues I came across, especially doing like more complex curves like you described, was trying to figure out like the logic for the unlocking the pool and like settling the deltas. And I was just wondering, when you were like kind of going through the process of experimenting with like new curve designs and stuff like that, like how did you go about sort of handling deltas? Like, did you have any advice for like hook builders who were trying to like grok that? And yeah, just any advice in general about like that part of hook building would be really, really useful.
Yeah, it's super complicated. That's actually why we added a function. This is midway through the audits. There's a function in core that we added, clear, that basically just removes dust. So like right now, before that function, if you had like some dust left over because you didn't exactly calculate it or there was some precision loss or whatever, it's really annoying because you just revert or whatever. You can't figure it out why. Clear is something that we actually integrated in our peripheral code. So if you go look at the position manager, we have a action called clear or take. Basically that says if there's a delta open and it's like, you can program it. Like in our test, we're like, okay, if it's less than like 100 way, like clear it. Otherwise, we want to take it. That's a really nice way to be like, okay, we don't actually really care about dust, and we want to make sure the transaction doesn't revert, so we can use that. That's really cool. The other thing we wrote is there's a contract in, I think a lot of contracts in Periphery where we're writing integration code with core, like a lot of those contracts hook developers can use and build off of. So one, like I mentioned, is the actions router, and we have a contract called base actions router that basically does nothing, and so you can like inherit it and write your own actions and do your own, like customize this actions router, which is really great. We also have this contract called Delta Resolver, so it handles like the sync transfer settle process of like integrating with core, which is really gnarly and definitely like could be a foot gun for a lot of users. And so I would recommend looking at that contract as well. And it handles a lot of the integration with take settles, etc.
Sorry, what was that last one called again?
Delta Resolver.
Perfect. Thank you.
Thanks, great presentation. I'm curious, among all the pull requests that your team reviewed, like the external one, over a year, have you noticed any pull requests that, looked a bit shady or maybe, almost malicious?
No. Pretty much all of the community contributions were like really positive. So it's more just something we have to keep in mind when we look at reviews. There's definitely PRs that we didn't accept. I think sometimes when we look at code and there's a lot of assembly or it touches really core critical paths, we're a little bit less likely to want to merge something like that with such big changes. With that being said, we still made some pretty interesting changes to paths here that were written by the community.
Okay, thanks.
Cool, thank you.